8.3 is on the standard normal distribution. All right, and that is a special version of a normal distribution. The mean of the standard normal distribution is equal to 0, and the variance, which is, let's see, is equal to 1. So that means that the standard deviation is also equal to 1. The distribution, or this distribution, provides a basis for computing probabilities for all normal distributions. And so we need to really get a grasp on this before we start using z-scores and things like that to help us figure out probabilities. The way that I explain this personally, well, I've taught this for the past 12 years. I teach it a little bit different than the book. Your book does a really good job, but it uses table A in the appendix to explain how to do this. I use tables B and C because they make, just for me personally, they make a little bit more sense. And let me show you the difference in the tables really quick. All right. Appendix, this is Appendix A, Table A, starts off with positive z-scores here on the left, and the values that are given in the table are areas which correspond to an area under the curve from the middle here at 0 to the right. So if you see this shaded region right here, imagine you have a z of any positive number, then the area, the value that's given in this table is the area between the middle and z under the curve, which corresponds to a probability. The tables that I use, I told you I use table B and table C. It does the same thing. Table B has negative z-scores, which you would have to use, you have to, without using symmetry, you're going to have to use a table that has negative z-scores. And so it does the same thing, it's just this table has negative z-scores, so any value, any z-score that's negative, whenever you look up that z-score in the chart, you will get the area under the curve, all right, which corresponds to a probability, because the area under the curve equals 1, all right, and we know that the sum of all probabilities is equal to 1. It just so happens that this normal curve does correspond to a probability. So the areas, all these numbers here, all these decimals, are going to be the area under the curve up to that value of z. So it's cumulative left to right. All right. Table C is for positive z-scores, and it's also cumulative left to right. So table B and table C kind of use the same logic. The area that you get here is always cumulative left to right. That's different from table A because table A just gives you an area from the middle here to the right. Okay, so in my opinion, it's a little bit easier to understand how to find the probabilities when we start working out problems by using just table B and table C. So, yes. All right, so how can we, or what type of problems could we use this on? We're going to start really simple with the standard normal distribution. So let me pull back up your book really quick. And so I'm going to be, see, around page I'm around page 340 of your ebook. And let's look at this problem here. It says, determine the probability that a standard normal random variable is between negative 1.08 and 0. Now there, just like with most math problems, there are several ways to get to the same answer. I'm just going to show you the way that I learned and that I've always taught. Okay, so with a standard normal distribution, remember the standard deviation is 1 and the mean is 0. So what that means is, even if we plugged it into the z-score formula, we would get negative 1.08 and we would get 0, because the z-score formula is x minus mu over sigma. So if you subtract nothing and you divide by 1, you're getting the same number. Alright, so if we want to know the probability that the variable is between negative 1.08 and 0, then I'm going to draw a picture to show you exactly what we're getting. I'm just going to draw the regular x and y axis to kind of give me a guideline to go by. And here's my normal curve. I know that right here in the middle, that's 0. And then a negative z-score is always to the left of 0, just like on the number line, how we have positive numbers to the right, negative numbers to the left. It's the same with z-scores. So somewhere out here I have a z-score, or I have a value of negative 1.08. Now I want to figure out the area between these two values. So I'm trying to figure out this area here. Now like I said, there are several ways to get that answer. But the way that I would suggest getting that answer is first finding the area from left to right to 0. So figuring out all of this shaded region here. So if I can look in the table and find a value for all of this up to 0, then find a value for the area up to negative 1.08, which would be from here to here. Then I'll take the larger area, subtract the smaller area, and that will give me the area between the two. It sounds a little confusing at first, but it's really not that bad. So I'm finding the area cumulative from left to right up to 0, and then I'm going to subtract the area cumulative from left to right up to negative 1.08. And if I want to know the probability that a standard normal random variable is between those two, that will give me the answer. Okay, so the area under the curve is 1. We don't even have to use a table to get the area from left to right for 0. Because remember, 0 is right here at the halfway point. So if the area under the curve is 1, then half of that area has to be 0.5. but we can still use the table to get that. Okay, so I'm going to go to Appendix B, or Appendix A, Table B, real quick. And if you don't have a copy of that appendix or that table, I can print one out for you. Alright, so you see right here, this has the negative z-scores. I wanted to find the z-score for 0.0 first. Alright, so all z-scores are always rounded to 2 decimal places, and if I wanted 0.0, it's on both tables, but here's 0.0 and then here's the hundredths digit at the top. So 0.00 is going to be on the last column, so the very last value, and it may be a little tough for you to see up here, but it's 0.5000. So you don't have to use a table to get that, like I said, because half of the area under the curve is at 0, and that's 0.5, but the area cumulative from left to right will be 0.5. So it probably would be best for me to say this would be the probability that z is less than 0 is equal to 0.5. So that's all of this. And I'll explain what less than and greater than means with the standard normal curve in just a second. Alright, so if I want to find the area between the two, I need to find the area up to negative 1.08. So this will be the probability that z is less than negative 1.08. And so that is the way that all of the areas are shown in the table. They're shown cumulative left to right, which actually, in terms of inequalities, means less than. Okay, so I need to find an area for negative 1.08. So negative 1.0 is right here. And then I'm going to go over to, went over too far, I'm going to go over to the eighths for hundredths. So that's negative 1.08. It's 0.1401. 0.1401. So that area is 0.1401. Alright, so let me show you what I have written down here. I'm going to draw two more graphs. This first area here is for a z of 0. So we figured out that here at 0, all of this area to the left under the curve is equal to 0.5. Then we figured out that all of the area under the curve from a z of negative 1.08, all of the area under the curve up to that value right there, that was 0.1401. So if I want to know the area between the two, then I can take the larger area, subtract the smaller area, and that will give me the probability that a data item or a standard normal random variable would be between negative 1.08 and 0. Okay, so I would simply say 0.5 minus 0.1401, and that would give me the area between the two. All right, so I got 0.3599. All right, so now let me explain to you in more detail. Let me see if I can find a problem that says either greater than or less than or something like that. Or I could really just make one up. Give me just 1 second. Alright, so you may want to write this problem down because I'm going to kind of make these up and so we can understand a little bit better, or we can get a little more practice working under the curve. Alright, so determine the probability that a standard normal variable is less than 2.13. Now again, this section that we're covering is very special in the fact, or in the regards that the mean is equal to 0 and the variance or standard deviation is equal to 1. So I said earlier, and it may not have made as much sense, but if I plug in a 0 for the mean and I plug in a 1 for the standard deviation, I would get out the same number that I put in. Okay, that doesn't always happen. That just happens with a standard normal distribution. All right, so what we're looking at here is we want to, and I'm going to draw a picture, kind of try to make it make a little more sense. So here's our bell curve. Now a z of 2.13 is going to be on the right side of 0, right? Here's 0, and what these z's are, remember, they're standard deviations in a way. They're a standardized value away from the mean. So that 2.13 is probably going to be pretty far over here to the right. So I'm going to just say right here, this is 2.13. So if I want to know the probability that a standard normal random variable is less than this value, less than means I want the area to the left. So it's going to be all of this. Now the way that table B and table C work, all of the areas are cumulative left to right. So if I look up a z-score of 2.13, then that will give me the area to the left of 2.13. So I'm going to go back to my table. Alright, so here's my table here. Is this the table that I need? No, because this has z-scores that are negative. So go to the positive z-score table, it's table C. Go down 2 0.1 and then over to the 0.3 column. So 2.13, that's 0.9834. So the probability that it's really that our x, but I'm going to just put a z, it's x is less than, but this is, on these problems, it's the same as z. The probability z is less than 2.13 was that 0.9834. I'll try to figure this problem out. Determine the probability that a standard normal random variable is less than 1.35. So if we use table C, remember the area is cumulative left to right. So any problem that has less than, I can just take the value out of the table. So go to a z-score of 1.35, and that gives you an area in the table of 0.9115. All right, so that means the probability that z is less than 1.35. For what we're doing, that's actually the same thing as probability that x is less than 1.35. So if you see it written like that, it means the same thing in this section. All right, and that's going to be equal to that number, whatever I said, 0.9115. Now, to draw a picture, just to show you what we're doing, here's the area, here's the standard normal curve. We have a z-score of 1, or an x value of 1 in this case, somewhere around here. And so we're figuring out this area, which corresponds to a probability. All right, so that's less than. If we wanted to do the same thing, let's do the exact same problem, except I'm going to put is greater than 1.35. Okay, so what I'm trying to figure out, and compare what I'm about to draw here. Whoa, that's a crazy normal curve. That's not a normal curve. Okay, let's pretend that's a normal curve. Then, okay, so I have a z-score or an x value in this problem, 1.35. If I want to know greater than is the area to the right. So how could I figure out the area to the right by using the area to the left? That's right. We know that the total area under the curve is 1. So if I say 1 minus the probability that z or x, in this case, if you want to be technical, they're using x, is less than 1.35, this right here, 1 minus what we got before, will give us the area to the right. Okay, so that would be 1 minus 0.9115, or .0885. All right, so less than is the area to the left. That's the way that Table B and Table C have areas listed. Greater than is going to be the area to the right. So you say 1 minus the area that you get from the table. If you need the area between the two, like the first problem that I worked out, probably not the best way to start out, but if you need the area between the two, find the area of the one furthest to the right, and then subtract the area of the one furthest to the left. That will give you the area between the two. So let's work one more. Alright, so let's determine the probability that a standard, normal, random variable is between negative 1.26 and 2.05. I'll give you a second to work that out. So, since area in tables B and C are cumulative from left to right, to find the area between two values, find the area of the rightermost value. That would be, on this problem, 2.05. So if we use our table C, 2.05 is 0.9798. 0.9798 is the area from left all the way to 2.05. Alright, and if I want to find the area between that and something else, I need to find the area of the far left term and subtract that. So the left value is negative 1.26. So if you go to table B, negative 1.26 is going to be 0.1038. So minus 0.1038. .9798 minus 0.1038. I get 0.876. So what that means is this shaded part up here, that's 0.876.